Chapter 13, WLAN Configuration. The wireless router. These wireless routers typically provide WLAN security, DHCP services, integrated name address translation, quality of services, as well as variety of other features. The feature set will vary based on the router model. Log into the wireless router. To gain access to the wireless router's configuration GUI, open a web browser. In the address field, enter the default IP address for your wireless router. The default IP address can be found in the documentation that came with the wireless router, or you can search the internet. The basic network setup. First, log into the router for a web browser. Change the default administrative password. Log in with a new administrative password. Change the default DHCP IPv4 addresses. Renew the IP address. Log into the router with the new IP address. Basic wireless setup. View the WLAN defaults. Change the network mode. Configure the SSID. Configure the channel. Configure the security mode. Configure the passphrase. Configure a wireless mesh network. Extending a WLAN in a small office or home has become increasingly easier. Manufacturers have made creating a wireless mesh network simple through smartphone apps. You buy the system, disperse the access points, plug them in, download the app, and configure your WMN in a few steps. Search the internet for best Wi-Fi mesh network system to find reviews of current offerings. Not for IPv4. The 209.165.201.11 IPv4 address is publicly routable on the internet. Any address with the IO in the first octet is the private IPv4 address and cannot be routed on the internet. Therefore, the router will use a process called network address translation to convert private IPv4 addresses to internet routable IPv4 addresses. The process is reversed for incoming packets. The router is able to translate many internal IPv4 addresses into public addresses by using NAT. Quality of service. The figure simply mock up as QoS interface based on a Netgear GUI. You will usually find the QoS settings in the advanced menus. If you have a wireless router available, investigate the QoS settings. Sometimes, this might be listed under bandwidth control or something similar. Consult the wireless router's documentation or search the internet for QoS settings for your routers. Make a model. Port forwarding. Port triggering allows the router to temporarily forward data through inbound ports to a specific device. You can use port triggering to forward data to a computer only when a designated port range is used to make an outbound request. For example, a video game might use port 27,000 to 27,100 for connecting with other players. These are the trigger ports. A chat client might use port 56 for connecting the same players so that they can interact with each other. WLC topology. LAPs use the lightweight access point protocol to communicate with a WLAN controller. Controller-based APs are useful in situations where many APs are required in the network. As more APs are added, Each AP is automatically configured and managed by WLC. Log in to the WLC. The network summary page is a dashboard that provides a quick overview of the number of configured wireless networks, associated access points, and active clients. You can also see the number of rogue access points and clients. View app information. The app is using IP address 192.168.200.3 because Cisco Discovery Protocol is active on this network. The WLC knows that the AP is connected to the Fast Ethernet 01 port on the switch. This AP is the topology is a Cisco Aeronet 1815i, which means you can use the command line and a limited set of familiar iOS commands. Advanced setting. Most WLC will come with some basic settings and menus that users can quickly access to implement a variety of common configurations. However, as a network administrator, you will typically access the advanced settings. For the Cisco 3504 wireless controller, click Advanced in the upper right-hand corner to access the Advanced Summary page as shown. From here, you can access all the features of the WLC. Configure a WLAN. Wireless LAN controllers have ports and interfaces. Ports are the sockets for the physical connections to the wired network. They resemble switch ports. Interfaces are virtual. They are created in software and very similar to VLAN interfaces. In fact, each interface will carry traffic from a WLAN is configured on the WLC as a different VLAN. The Cisco 3504 WLC can support 150 access points and 4096 VLANs. However, it only has 5 physical ports. This means that each physical port can support many APs and WLANs. The ports on the WLC are essentially trunk ports that carry traffic multiple VLANs to a switch port distribution to multiple APs. Each AP can support multiple WLANs. SNMP and radius. SNMP is used to monitor the network. The network administrator wants the WLC to forward all SNMP log messages, called traps, to the SNMP server. The credentials will be verified by the radius server. This way, individual user access can be tracked and audited if necessary. If user accounts can be added or modified from a central location, the radius server is required for WLANs that are using WPA2 enterprise authentication. Configure SNMP server information. Click the Management tab to access a variety of management features. SNMP is listed at the top of the menu on the left. Click SNMP to expand the submenus. Then click Trap Receivers. Click New to configure a new SNMP trap receiver. Enter the SNMP community name and the IP address. For the SNMP server, click Apply. The WLC will now forward SNMP log messages to the SNMP server. Configure radius server information. Click the Security tab, then Radius, then Authentication. No radius server are currently configured. Click New to add PCA as the radius server. Click New. Enter the IPv4 address for PCA and the shared secret. This is the password used between the WLC and the radius server. It is not for users. Click Apply. After clicking Apply, the list is configured. Radius authentication servers refreshes with the new server listed. Configure a new interface. Create a new interface. Configure the VLAN name and ID. Configure the port and interface address. Configure the DHCP server address. Apply and confirm. Verify interfaces. Configure a DHCO scope. Review the topology. Explain the role of the WLC DHCP server. Create a new DHCP scope. Configure a WPA2 Enterprise WLAN. Review the topology. Create a LAN. Configure the WLC to use the radio server. Secure the new LAN with WPA2 Enterprise. Verify WPA2 Enterprise security. And that's all. Thank you.